Hi, this tutorial is for October 18th, and we're looking at this particular set of notes that we did yesterday. If this is fourth hour, I really need you to go. Some students actually left, like I think Noah and a couple of other students left this on their desk, and I took it and I put it on the teacher's desk. So if you could go and ask up to my desk and ask if yours is on the desk, or if the substitute can pass it out, that'd be great. I need everyone to have a copy of this. If you don't have a copy of this, you can get, I guess, the rest of the work from me when I get back on Monday. We're working on the back side now, and we're looking to write an equation in slope-intercept form. Once again, it's y equals mx plus b. That is slope-intercept form, where m is the slope, b is the y-intercept, and we're always going to begin with b, then graph your slope. So if you have a formula that's y equals mx plus b, there's no constraints on whether it can be a fraction or a negative number. It doesn't work like that. So we just want to make sure that we have our m, our x plus b, and our y is isolated, getting y alone, or f of x. So in this case, I graph my b, my value of my b, which is 7, and I graph it at 7. Now I could go up to and over 5. However, that's off the graph. So I could, instead of going up 2 and right 5, I'm going to reverse it and go down 2 and left 5 and plot my point. So I could either go up 2, right 5, or down 2, left 5. So I can just plot my point and plot more points and continue on. So you always begin with the the y-intercept. So in this case, my y-intercept is 2. That's where I'm going to begin. And I'm going to plot a point on the y-axis, my y-intercept, where it is 0, 2. Now my slope here, my m value, is a negative sign, which is really negative 1 over 1. So from there, I'm going to go down 1, which is the negative, and right 1. Down 1, right 1, down 1, right 1. And I'm going to connect these dots. Okay. Now, number 9 is actually in slope-intercept form. No, it is not. Try that again. Mrs. Burkett is having a late night. It is in standard form. We need to get it into slope-intercept form, and we have to get y alone. We have to isolate y. So our first step is to rearrange and rewrite this so that we're out of standard form. And I remember on the front side, we worked so hard to get in standard form. Now we're trying to get out of it and solve for y. So I'm going to subtract x. So I get 3y equals negative x minus 15. And then I have to get y alone, and it's 3 times y. So I'm going to divide by 3 to each term. So I have y equals negative 1/3 x. Now negative 15 over 3 is negative 5. Okay, so this y is isolated. I have my mx plus b, which happens to be at negative 5. So 1, 2, 3, 4, 5 down here. And from that point, I'm going to go down 1, right 3. 1, 2, 3. From the y-intercept, I could also go opposite. Instead of down and right, I could go up and left. So I can go up 1, left 3. 1, 2, 3. And connect the dots to look like this. Okay. Number 10, to get it into slope-intercept form, not standard form, but slope-intercept form, we have to get y alone. So we can start by, if you want, adding 1. Sure, why not? So I've got 4x plus y equals 1. There's your standard form, but we're not trying to get that. I'm going to subtract 4x from each side of the equation bridge. I get y equals negative 4x plus 1. You always begin with your constant, your y-intercept. Begin with b for begin. And now my slope is negative 4, which is really negative 4 over 1, which represents down 4, 1, 2, 3, 4, and over 1. I can keep going. 1, 2, 3, 4, and over 1. And you connect with a smooth line. All right, so now that we are finished with this backside through 10, there are 2 sheets. There's an exercise 3.1, and then there's another homework sheet. I would like you to do exercise 3.1 first, and then the other homework sheet, which is just going to be evens. But if you don't get it done in class, it is homework due Monday. All right, have a great weekend. I miss y'all. Bye-bye.